The James Webb Space Telescope, JWST, is the top international tool for studying space. It's all about figuring out the mysteries of our solar system, finding planets around other stars, and understanding how everything in space is put together, including us. Recently, some researchers did something really cool. They pointed the JWST at a star about 120 light-years away. What they found was super interesting. The telescope spotted clues that there might be carbon stuff in the air of a planet far, far away, a planet that could even have oceans. This blew scientists' minds. So how did they do it? This discovery gives us an awesome look at a planet that's way different from the ones we know, and it makes us wonder if there are other planets out there that could support life. Let's check out this exoplanet and the cool details it's showing us. If you want to keep up with the latest space news, hit subscribe, like this video, share it, and turn on notifications. NASA's James Webb Space Telescope has made a crucial find about the exoplanet K2-18b, which is almost 9 times bigger than Earth. What's so exciting is that they saw carbon gases like methane and carbon dioxide in its air. This backs up earlier ideas that K2-18b might be able to have life. It looks like it has a lot of hydrogen in its atmosphere and maybe liquid water on the surface. The Hubble Space Telescope also checked out this exoplanet, which helped us learn way more about it. Just so you know, K2-18b is about 120 light-years away, in the Leo constellation. It goes around a dim star called K2-18, which is in the right spot for the planet to maybe have life. Planets like K2-18b, between the size of Earth and Neptune, aren't common in our solar system because we don't have anything like that here. The idea that K2-18b might have a bunch of carbon and a hydrogen-filled atmosphere is really interesting to scientists. A lot of them think these kinds of planets might be the best place to look for signs of life. Finding methane and carbon dioxide and not seeing ammonia makes them think this exoplanet might have an ocean under its hydrogen-rich skies. Initial studies mentioned the possibility of finding dimethyl sulfide, which on Earth is made by tiny sea plants. Still, we need to double-check if it's really there on K2-18b. More checks with the JWST should help confirm if there's much dimethyl sulfide in the planet's atmosphere. One scientist from Cambridge said that, while K2-18b could have liquid water and carbon stuff, that alone doesn't mean there's life. Since the planet is over twice as big as Earth, it probably has a thick, icy layer like Neptune, plus a thin atmosphere full of hydrogen and maybe oceans on the surface. Even if there's water, those oceans might be too extreme, too much pressure or weird chemicals, for life as we know it. But still, scientists now have the clearest view ever of the atmosphere of a sub-Neptune planet, which lets them see what's in it. A scientist from Cardiff University said they figured out how to study the starlight as it went through the exoplanet's atmosphere. K2-18b is a transiting exoplanet, which means it dims the light of its star as it passes in front. NASA's Kepler mission found the planet this way. When this happens, some starlight goes through the exoplanet's atmosphere before reaching us. Telescopes like the JWST can see what's in that light, which helps scientists figure out what gases are there. The researchers want to do more tests with the JWST to confirm what's in the atmosphere and learn about K2-18b's weather. What they really want to do is look for signs of life on planets that could support it, which could totally change what we know about life in space. Besides that, the JWST has made other great finds. Astronomers have seen complex carbon stuff like soot in a galaxy far away. This stuff showed up earlier in space than we thought. Personally, I think this is inspiring because these space finds are changing our ideas about the universe. What's key here is that these molecules, called aromatic hydrocarbons, were found in a galaxy that formed when the universe was only 10% of its current age. These carbon molecules, common in oil, coal, and air pollution, are big and complicated with tons of atoms. What's surprising is that these complex molecules showed up so soon after the Big Bang, which goes against what we thought. So, the light we're seeing from this old galaxy started traveling only 1.5 billion years after the Big Bang. The universe is about 13.8 billion years old now, so we're seeing some of its earliest times. What's even cooler is that the Webb telescope let us see this and will keep letting us make finds like this for another billion years of space history. If we could see even further back, would we find even more of these molecules closer to the start of the universe? This brings up big questions about how we understand the universe. Before, scientists could only say that these molecules existed in the early universe, but now we can see exactly where they are. Plus, it's weird that these molecules aren't spread out evenly in the early galaxy. What's really amazing is that this galaxy was already about the size of the Milky Way and had made a similar amount of carbon and oxygen, even though it was much younger. As we keep moving into space, guided by knowledge and science, we're always shocked by how huge and complex the universe is. Every new find helps us solve the mysteries hidden in space. As our space research gets better, it's only a matter of time before the universe shows us even more of its secrets, helping us see where we fit in. Share your thoughts in the comments below. If you like this video, remember to hit subscribe and turn on notifications. As our knowledge of the cosmos grows, the James Webb Space Telescope is always providing us with revelatory insights. Its observations are changing how we think about distant planets and celestial formations, expanding the limits of our cosmic understanding. This telescope enables us to look deeper into space than ever before, unveiling questions that long eluded scientists. The detection of intricate carbon compounds in ancient galaxies is just one example of how JWST is improving our understanding of the early universe and how it has grown over time. One of the key things about these discoveries is the idea that life, or at least what it needs, might be in places we thought were unlivable. Finding carbon stuff in the air of planets like K2-18b opens new ways to study if there are signs of life on worlds like Earth. These substances, like methane and carbon dioxide, are often tied to life processes here, but seeing them on distant planets doesn't prove life exists. It just makes us want to look deeper to see if life could survive there. NASA's future missions will focus on this even more. The JWST's accuracy in studying exoplanet atmospheres is a big step forward. It helps scientists find not just basic stuff, but also complex chemical signs that could hint at life. This detailed view is important for seeing if planets far away could really be habitable. As we understand more, we can better spot signs of life, whether that's through gases in the atmosphere, carbon leftovers, or other things that point to biology. Besides studying exoplanets, the JWST is also giving us key info about how galaxies form and change. By looking at old galaxies, astronomers can see how stars formed, how stuff is spread out, and what forces change galaxies over billions of years. This helps us understand how our own galaxy, the Milky Way, came to be. The find of hydrocarbons in a galaxy that formed much earlier than ours shows how much we're learning about the start of the universe. But as we keep exploring space, every new insight brings us closer to answering some of the most meaningful questions ever asked by people. Are we alone? How did life start? What will happen to space in the end? These are questions that have interested scientists and thinkers for centuries. Now, with tools like the James Webb Space Telescope, we're better than ever at finding those answers. Every breakthrough expands our view of the universe and takes us closer to knowing the truths that are beyond the stars. The signal from K2-18b. Elena Marquez stared at the data on her screen in the JWST Command Center, forgetting her coffee. The air tests from K28 billion were like nothing she'd seen. Methane, carbon dioxide, and even dimethyl sulfide compounds that on Earth whispered of life. Her heart raced, wondering if this distant planet may really have life. Elena, you seeing this? Her colleague, Dr. Raj Patel, leaned over her shoulder, his voice barely containing excitement. Elena nodded, her eyes fixed on the spectrograph. The command room buzzed with quiet anticipation. The team at NASA's guarded Space Flight Center had been working around the clock since the initial K2-18b findings. The exoplanet orbiting a cool dwarf star had already defied expectations. And now this possible biomarker had turned their research into a global sensation. Elena's thoughts drifted to the mission's next phase. The JWST's instruments were set for another look, with a chance to confirm the dimethyl sulfide. She imagined the probe piercing the planet's atmosphere, heading toward an alien ocean. Dr. Marquez, you're needed at the briefing room. A voice crackled through her comms. Elena exchanged her glance with Raj before heading there, her mind racing. In that room, a display projected K28b's hazy blue-green sphere. Nguyen stood at the head of the table, joined with scientists. We've intercepted something new, Nguyen said. A signal, faint but structured, embedded in the starlight. It's not natural. The room fell silent. Elena's breath caught. A signal? She asked. Like it's a communication? Mune said, we don't know yet. Could be an error or it could be something else. As the meeting ended, Elena's mind spun. A signal from 120 light-years away. The implications were staggering. She returned to her station where Raj was already pulling up the raw data. The signal was a rhythm unlike any noise they'd catalogued. Felt like a radio beacon. As the telescopes turned toward K28b once more, Elena couldn't shake the feeling that they were on the brink of something monumental. Were they about to confirm life or something even stranger? The ocean calling, and humanity was finally ready to listen.